Hi, welcome to the second of the AQA CompSci NEA Enlightenment videos. We're going to look a bit more at analysis and really what formal analysis techniques you need to include in your documentation. I want to remind you of the MARC scheme. Requirements arrived at by considering through dialogue the needs of individual user system recipients the outcome of investigated projects, problems sufficiently well modelled to be used for subsequent stages. That well modelled is absolutely key. Really part of this idea of being fully scoped and the requirements are fully documented. We'll come to requirements later. But that well modelled is key, and that's what we're really after today, modelling the problem. So what do we need to do to really be fully scoped and well modelled? Ultimately, computer scientists want to take a problem, abstract it, create a model, and communicate that model through a series of formal techniques, usually diagrams, usually visualizations, so we can get a clear handle on what's happening. So, what are you going to do? For the real world, you can write just a list of users, maybe a nice organization chart, just so people can see who's going to be using it. Right, now onto the system itself. Process. There's nothing wrong with a good, honest flowchart. Please do not try and create one flowchart that describes the whole system. It's horrible, it's a nightmare. Flowchart specific elements of the system. And using pseudocode or structured English would be better, but there's nothing wrong with a flowchart. I'm a big fan of at this stage you saying, here's my key points, and actually trying to break it down in a bit of stepwise refinement. No one's going to have a problem with using sort of really step-by-step techniques. So if you don't know, oh, by the way, what I would say is during this video I am not going to try and explain each of these diagrams. They're well documented. I'm going to link to other videos that explain how to create these different diagrams, and if I can't find one, I'll do a quick summary on how to create the diagram. But generally speaking, I'm going to assume that there's other resources out there that will help you actually create these diagrams. This is just a video to say what I want, or what I feel would be advantageous to your project. So IPSO, so input, process, storage, output diagram, just simple lists. A case diagram, you might need to look that up, but it's similar to a decision chart. I've not got a slash there, but hopefully you're familiar with a top-down chart or a hierarchy chart, or maybe a structure diagram. And if you've got a really mathsy system, just a good honest derivation of a function saying, this is the process, this is the function I want to use, here's how I got to it. There's nothing wrong with a bit of math derivation. I think every single one of you should aim to be creating your project in the object-oriented paradigm. I think almost all the investigations and certainly all of the end-user projects are asking to be developed in the object-oriented paradigm. So you need a class diagram or an object diagram, you might have heard it called. This is the one that students always find tricky, and I think you start with a level 0, move to a level 1 data flow diagram, don't go too much further than that. And with all of these, but I think data flow especially, don't worry that if on your first draft you've got to get it perfect. Give it your best shot. See if what you've created really sort of communicates your model, your understanding. And don't forget, actually, nobody else has researched your project. So if there's a tiny little mistake in some of your modelling, hopefully it won't affect the end solution, but it probably won't get picked up So I'd rather you are confident, create some diagrams, create a model, develop your understanding, and then really worry and spend hours trying to dot every I and cross every T in each of these diagrams, get them knocked out, and hopefully as you create them you can go back and revise them. Something that I think every single project will need, whether it's an investigation or a end user project, is a data dictionary. But of course, if you've got some good honest end user documents that you've captured, you're going to be creating a formal specification sheet which explains how often it's used and exactly all the data involved. I'm quite flexible on these last two. If you've got any data storage that's reasonably complex, you'll almost certainly want to do your normalization at this stage. If you end up putting it in design, it's not the end of the world, but it'd be good just to get a little entity diagram so you're starting to think about a real world model of how the data should be stored. If you are not storing vast amounts of data, at some stage you're going to have to define the file storage formats you're going to create. Might be you want to analyze those, or maybe if your data dictionary is pretty clear and that your model of data being stored in the running program is similar to the storage, then you can do that at design. But you know, you're going to want to at the very least think about it. And that is really, I think, if you've got quite a few of these techniques, we can say this is a really well scoped, if not fully scoped, analysis. With each of these diagrams, please just give it a few words to explain what you're trying to communicate. Sometimes I'll see people with like 10 data flow diagrams, and each of the little boxes are fairly cryptic, and the elements of data flowing through it you can just about work out, but it's of eye-watering. Just a line or two just to explain this diagram shows blah 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 really helps the reader. So I've kept the why for later. Why on earth do we analyze a problem in this formal way? Well, one, because we're computer scientists. It helps us to clarify our understanding of the problem. And as we get used to using these techniques, it means that we've got a set of tools that can cut apart a problem, that when we look back later on, we can remember, oh yeah, that's what I thought about this problem. And it might be you realise later on, my view of this problem was wrong, but at least I've got a really clear, documented model of what I thought the problem was about at that particular time, and that's why I made the design decisions. And it will help me evaluate, do you know what, that was a bad call because I misunderstood the problem. Therefore, this is the changes I can make. It also allows us to communicate to a third party, or of course, because this is an examined piece of coursework or non-examined assessment, the examiner, and this of course commercial could be someone who's going to go and design and build the system, or of course it could be an expert who's giving you advice, or it could even be the client, where they can sort of look at your diagrams and ask you questions and sort of check that your understanding is right. So what we're doing is providing a unified way of modeling the problem that lots of other people, hopefully, because they're used to these style of diagrams, understand. And apart from anything else, you're about to design a solution. You're about to sort of clearly list what's required. This provides you with a whole sort of set of views of the problem that remove the things that stop you producing a good solution. It abstracts it down. Usually, if you're doing this, there'll be other people in a team who'll be sort of arguing with you, saying, no, you don't want to do it like this, we need to include this. You haven't got that. You've got you producing this on your own. But we still need to see evidence that you've thought about it and assessed the pros and cons. Some people call it internal dialogue, other people call it critical discussion. Whatever you want to call it, it's vital if you want to get into the top band of marks. A minimum of a page. And what you want is to have a discussion. Each element of the problem, how you've interpreted that analysis, to really think, what conclusions is it going to lead you? If it's obvious, then just cut to the chase and give it a quick summary. So if you've said, I've looked and I need to store each of the, remember in the last video we talked about scout badges. I need to store a list of all the scout badges so people can select them, and they need to be able to be linked to Scout so we can quickly produce a report of which Scout has which badges, so that we don't try and put people in for the badge twice. I'm assuming everyone's vaguely aware of Scouts. Don't spend hours discussing the pros and cons of different ways of doing this. Just say that needs to be done. But there's going to be areas that are really not obvious. Some of this could be sort of hardware end user based. So, you could discuss whether you want to do it as an app or a laptop, a program that could run on a laptop, or a piece of embedded software on another device, whatever it happens to be. Don't go too left field. Thinking about the Scout badges, don't start thinking, let's really think, could we put an RFID chip on every badge so it can be quickly scanned on a Scout sleeve. Keep it fairly sensible. But where there's a thing, I could use this algorithm, or could use this algorithm, or could use this algorithm. This one's going to be a nightmare. This one's not really going to cut the mustard. So you're always looking for the Goldilocks, really, the ideal cost benefit. And don't be afraid to talk about hardware. But I'll warn you now, it's not going to get you a lot of marks. Unless, of course, you're doing a project with a significant hardware element. So if you're creating sort of robotics or something else that really sort of takes into account a lot of hardware, that's fair enough. But most of you, please keep it to algorithms and methods of input and what's required in terms of outputs and the process you get there. Just keep thinking ipso. You are genuinely trying to think about what is going to be needed. You're not doing this for the sake of it. If you think, I've already thought about this and it's exactly what I want to need to do, just think, how did I get to that decision? Why have I decided that I need to allow somebody to be able to just press a button and 10 things happen? Why have I decided that? And document your sort of decision-making process. The next video is going to be how you're going to create your list of requirements and give you a few examples of what I think are a good list of requirements and what a bad list of requirements. How can you make something that you can clearly communicate to your end user, this is what I'm about to create, is this what you want? And also at the end of it, especially if you're going to be selling this solution, this is what I said I was going to create. Look, this is what I've created. And for it to be effectively ticked off, and you can say, I have done exactly what I've said I've done. Your system required these 30 things. I have done the 30 things. Give me the paycheck. Or in terms of your project, give me the marks. Once you've done all that, just double check. All my analysis, can I see in my research where the data's come from, where the processes come from? If you know that you kind of observed a certain process and that's been expressed in a flowchart, or, and this is a real risk, because you have knowledge of the domain, i.e. you already know the system, you kind of jump to the analysis without communicating any research. You might need to go back in and backfill a little bit of research. Keep it short, but just make sure that there's a link. Especially after you've written your requirements, go back and check, is there some analysis that kind of backs up all the requirements? Is there any gaping holes where I've kind of just given it my best guess what's needed? There is, might do some backfilling. In your analysis, can you clearly see that you've worked out what inputs, what outputs, what processes and what storage is required? I know this is like really sort of computer science 101, but ultimately it's foundational. We can go into more detail, but if you haven't covered those 4 bases, if you're saying, oh, I don't appear to have any storage at all in my system, you need to really question, do I really not have any storage? Have I really got a system that just doesn't store anything for the next time at all? Because if you have, you need to check probably with your teacher that that's an appropriate system. Now, I'm going to talk about the requirements, and clearly, as I've just said, going back and revising, further analysis, redocumenting is perfectly acceptable. I'm not a huge fan of the system lifecycle where everything tries to get done in one go. But what you want to do is try and get especially as your project has got a very, very limited lifespan and very, very, very tight deadlines, you're going to want to do as much as possible on each of the stages of the system lifecycle. But if you're familiar with Agile, it's perfectly reasonable sort of to do it as you go along. What I would say is, for A-level projects, that is phenomenally risky. The systems lifecycle is kind of a safer way of ensuring that you don't hit a blind alley and crash and burn. Right, that was the second video. Hopefully you found it useful. Please look on this YouTube playlist for the links to videos that show you how to create a DFD or a flowchart or all the rest of the other things. They won't all be created by me. Thankfully there's lots of other teachers that have already produced things like this. There's also some videos that link to advice for the old coursework system. I think they're really useful to look at, particularly if you're doing an end user project. For an investigation, not so much. Hopefully you found that useful. Feel free to ask me questions in the comments, and all the best. I hope your project goes well.